Good afternoon. My name is Trent Martin. I'm with Intuitive Machines. On the South Pole Hopper, I am one of the principal investigators, the technology principal investigator. Dr. Robinson from Arizona State is our science principal investigator on this mission. I do have several other roles at Intuitive Machines. I'll let Ben talk to those later when he comes up here. What's a South Pole Hopper? So we were looking at a technology to provide extreme mobility into things like permanently shadowed regions on the South Pole or anywhere on the moon. We proposed to the NASA tipping point opportunities a technology demonstration of a hopper that could hop off of a lander, or in this case, our lander, down into a permanently shadowed region or into a pit or perhaps even into a tunnel. So we developed this technology and presented it to NASA. They picked it as part of a tipping point proposal. The original idea was that we would demonstrate the technology, we'd demonstrate the hop, and we would simply have cameras on it. Scientists being scientists, we couldn't help but add instruments. So we've since added a pyrometer and a neutron spectrometer to this demonstration. And because we were flying it with our Nokia tipping point as well, we added an LTE antenna to the system. So besides a UHF antenna, we also added an LTE antenna. At this point, though, it's full. However, in the future, we will be using this same technology to provide extreme mobility into wherever you'd like to go on the moon. So if you have a technology and you'd like to fly it into an extreme location, come see me. I can probably find you a way to get there. We're flying it on our IM-2 mission. Ben is going to talk about all of our IM missions here in a little bit. Maria talked about some of them already. But in this particular mission, one of them was Eclipse mission, so our Eclipse opportunity, that was the prime one. Two of them were tipping point. So we created an entire mission out of 3 different opportunities with NASA. So the Micronova Hopper, which we're building internally, the Prime 1 drill, and the M-Solo mass spectrometer, and the Lunar Outpost and LTE communication system. We actually have a few other payloads on those same missions because these are commercial missions and we can sell other opportunities, including things like satellite deployment into orbit around the moon, which we do on pretty much all of our missions. The engineering goals of the South Pole Hopper are to demonstrate that we can deploy from the host lander, provide proper power management, end-to-end communications, autonomous flight for predetermined locations, autonomous hazard detection and avoidance, and a constant altitude traverse flight profile and flight into and out of a PSR. Our original concept was, why waste a very good guidance, navigation, and control system that lands on the moon? Why waste that? Why not take that off of the lander and fly that into another location? So essentially, the camera systems that we use on this are the same systems that we use to land on the moon. We just added a propulsion system and a computer system that allows us to go take it somewhere else. That was the original intent. In reality, what we ended up with was a completely different package so that if someone else wanted to put it on their lander, they could fly this same instrument. The science goals are to look for geologic context and geotechnical properties at the Shackleton de Gerlache Ridge, which is where we're landing the IM-2 mission, in particular into and out of a PSR, and in this case, the Marston crater. Determination of surface brightness, temperature, and illumination, and shadow terrain, derive the surface roughness and thermal inertia of the illuminated polar regolith, and determine hydrogen abundance in the illuminated regions and within the PSR, and to supplement the horizon glow imaging after sunset. Some of the things that we're specifically looking for are this raindrop texture that was first noticed on Apollo 14 and Apollo 12. As we get close, really close images, as we hop, we're going to do 5 different hops with the hopper. We'll be able to get really close imagery at places away from the primary landing site. We'll look at soil properties. In this particular case, the image that you see there of the footprint was actually a science experiment done on Apollo 11, where they pushed down, or Buzz pushed his foot down as deep as he possibly could, and then they took imagery to see what would happen with the regolith. We can do the same kind of thing as like was done here on Surveyor 3 with the foot pad, where you can actually see how much the regolith compacts. We're going to do it where we're landing 5 times and have imagery of each of those. And then this elephant skin tree bark texture, first noticed in lunar orbit images in the 1960s. As we see this imagery from LRO and from other instruments that are measuring at the lunar surface, we'll be able to not only take this, but compare it to much, much closer imagery that we can do with our camera systems. We actually have, as I mentioned, an LRAD lunar radiometer provided by DLR. We have a neutron spectrometer provided by Pulley out of Hungary, two panchromatic CMOS cameras, a medium angle and a wide angle, and the LTE technology demonstration on this experiment, even though the original intent was just to show that we could fly a hopper off of a lander and prove that the technology worked. Here's some of the images that were recently gathered from our medium and wide angle camera systems at Arizona State. The camera systems are built by Canadensis in Canada. The ConOps for this mission: we fly on a Falcon 9. We launch out to a 380,000 by 185 kilometer highly elliptical orbit. We cruise to the moon in about 6 days. Unlike some of our competitors, it does not take us 3 to 4 months to fly out to the moon. It takes us 6 days to get to the moon. We go into orbit around the moon for about 24 hours before we land on the surface of the moon. One of the key advantages for that is that our avionics systems only go through the Van Allen belt one time. We don't go through multiple times as we're circling out to the moon. Nova-C lands, and then we do 5 hops with the hopper itself. The commissioning hop, that's 20 meters. The requirements hop, actually, I'll show you. Here we go. This is a better image of that. You can see where it says Nova-C, that's the initial landing site. We do multiple hops, one to get off the lander. We do a short parabolic hop. Then we do a hop with a steady level flight. Then a small hop down into the Martian crater, and then a hop back out of the crater. So in summary, the South Pole Hopper enables science and exploration in extreme terrains. The intent is to prove that you can reach environments like environments with a hopper that you cannot reach with a rover. And it provides a very valuable platform for aerial remote sensing in the lunar environment. So you guys all have instruments. I've seen them over the last 3 days. Come find me. We'll find a way to put them on a hopper, and we'll put them somewhere on the moon where you can get some really cool science done. Thanks.